Hi, my name's Kelly and I'm from the SMART program at the University of Newcastle. And we were really sad that we couldn't have you guys come out to campus and watch our fun science shows. But we're super excited that Children's University has asked us to be able to make some videos that we can share with you. The first thing I'd like to show you is elephant's toothpaste, and that's something you'd normally see at one of our science shows and you aren't able to do at home, but it's one of our favourites, so we'd really like to share it with you. We need to consider our PPE, and PPE stands for personal protective equipment. So the first thing that I would always put on is my lab coat, and that's to protect my clothes and my skin from any of the harmful chemicals. The next thing is safety glasses to protect my eyes. And finally are some gloves to protect my hands. I'm also wearing enclosed footwear in case that I spill any chemicals, that my feet are protected as well. Maybe you guys can think of some personal protective equipment that you've seen around. So for elephant's toothpaste, we need a chemical called hydrogen peroxide. I'm not sure if anyone has heard of this one before, but it's actually the chemical that hairdressers use to bleach hair. So I'm going to add 100 mils of hydrogen peroxide to my measuring cylinder. Or maybe a fraction over today. Then I'm going to mix up something called potassium iodide with some warm water. I'm going to add a teaspoon of potassium iodide, and it's a catalyst which is going to speed up our reaction. So I'm just going to add maybe 20 to 40 mils of water to get it to dissolve. And give that a bit of a stir. Usually warm water works best, but today, seeing as we're outside in this lovely environment, we're going to use some cooler water, but it is dissolving. I think everyone knows what this one is, dishwashing liquid. You've probably got some at home. I'm just going to add a little bit of squirt of dishwashing liquid. And today we're going to make green toothpaste. So a few drops of green food colouring. So ordinarily, if we were in a show, I'd love you guys to help me count down. So even though you're at home, can you guys help me count down? You ready? 3, 2, 1. Oh, there it goes. It was a little bit delayed, but look at it. Can anyone notice it's a bit hard to see that there's a bit of steam? Whoopsie! It's going it away. Anyway, it's an awesome reaction. You might have noticed there was a little bit of steam and you can see lots of the bubbles. But basically what's happening is that our hydrogen peroxide is breaking down into water and oxygen, and the soap is trapping those bubbles so that we can see them. Alright, I hope you enjoyed that. We've got some more to come, but they're things that you guys can have a go at home. Hi again, it's Kel from the SMART program at the University of Newcastle. As promised, here I am today with an experiment that you might like to try at home using some household items. The one I've got for you today is kind of like a magic trick as well, so you might like to test it out with your brothers, sisters or friends. So you start with a Ziploc bag, and we're going to fill it about halfway with water. Then seal the Ziploc bag, make sure it's sealed really well across the top. Everyone see that? So here I've got a really super sharp pencil, and I'm going to poke it through the bottom of the bag where the water is. And what do you think might happen? Shall we give it a go? I don't know if you can see that, but the pencil's staying and the water's not leaking out. Next, I'm going to try a pen and see if that works. A pen worked as well. Maybe if you don't have a pencil or a pen, you might have a skewer. Shall we see if the skewer works? It works really well. So you can see that the pen, the skewer, the pencil are all going through the plastic bag. So I've got a couple of extra pencils and skewers, so we might just try and see what happens if we push them through. And all of them have gone through and not one leak. Plastics are made from polymers and they're kind of like interwoven and they form a special seal. When it goes through, there's a special seal that forms around. But what do you think is going to happen when I take them out? Let's try. Oh, it's leaking. So that's a fun activity that you might like to try at home.
Hi, I'm Liesel. I'm here at the University of Newcastle with the SMART program. And we have another experiment for you to try at home, and all you'll need for this one is a piece of paper. And we're going to look at flight. So we're going to see if we can make a paper plane. Now when a plane flies, it has to work against gravity, which pulls it down, and it has to work against drag, which is pushing back against it, so that it can fly. So we need to create a design of a plane that is going to allow the plane to lift away from the earth, and also we'll have thrust, which is going to come from my arm, which is going to throw the plane. So I'll get you guys to grab a piece of paper and we'll come in a bit closer so you can see the folding. I'll show you a really good fold that makes a really neat little plane that hopefully is going to fly. Okay, so you're going to start, we're going to fold it long ways. So you're going to match up the corners and crease the middle. Make sure, use the edge of your fingernail to get a really good crease. Open it out again and we're going to fold into the middle line. So that top corner is going to come into the middle line, and once again you're going to create a really nice crease. Let's do that on the other side as well. Doesn't matter if they don't line up exactly, that's fine. Okay, nice crease. You're going to take that triangle that we created at the top and we're going to fold that right over. Okay, what you want to try to do is match up the point with the middle line, and again, really nice crease. Okay, fold it in half, again, recrease it, open her out. Okay, these top corners here, we're now going to fold into the middle, but we're not going to make a point. So when they fold in, you'll see that we don't have a point right in the middle. The point's off to the side a little bit. Doesn't have to be exact, it doesn't matter where. Just fold the other side in so that it meets it in the middle. Okay, you're going to fold that in half again, so it kind of looks like we've got the outside of a plane. All right, we're going to make the wings now. Now we're going to fold it so that it's a little bit down from that point here, and fold it out. Doesn't really matter what angle it is. You can flip it over and fold the other side to match. I'll just make sure these corners meet up down here, and a really nice crease. If you want to, you can fold these ones in a little bit, but you don't have to do that either. But if you do, just match them up on both sides. Okay, we're going to open those wings out. We've got a nice little plane. So how about we see if we can fly it?
Hello, I'm Matt, I'm from the University of Newcastle, and today we're going to build some little helicopters out of some very basic materials, including paper, and then something just to weigh down the bottom. So it can be a tiny little peg, some blue tack, or a little bit of aluminium foil. So we're going to start by grabbing our paper. Okay, so we're going to start by cutting the bit of paper into a long strip. Some very straight cutting. Excellent. We're going to cut our piece of paper into two halves, approximately half the length of the piece of paper, along like that. And we're going to start by folding our wings one on each side. Like this. Make sure you get that nice and straight, nice and even. Then we're going to go in about 1 centimetre from that, and we're going to cut across. About 1/3 of the way in on each side. Now we're going to fold those two sides in to create some weight on the bottom of the helicopter to pull it down through the sky. And then we're going to add our little weight. So this one we're going to use a tiny little peg, just a bit of weight on the bottom. And then the last thing we're going to do is we're going to add a little bit of pitch to the helicopter. This is just like real helicopter blades. It has a little bit of pitch to create a little bit of lift as it's falling down through the sky. So we make sure that they both go the same way so that it'll spin in one direction. And there it is. Okay, here's a few that I've made. We've got to put a couple of different things on the bottom. The first one I got is a peg. This yellow one I've got some blue tack. It's just some weight to pull it down using gravity through the air and to make the helicopter spin like that.
Hi, my name is Adam. As a kid, I was passionate about volcanoes and science, and so when I grew up, I wanted to be a researcher. So, to get to that, I went to university and I studied biology at the University of Newcastle, and then afterwards, I became a researcher and did cool science that helped make people's lives better. Today, I work as a science presenter, and I want to help teach everyone about science concepts so we can all help make the world a better place. So when I did research, I worked on tiny organisms called bacteria. And these tiny organisms are way too small for us to see, but they're very important. Did you know that each of us actually has millions of bacteria inside us? These bacteria aren't bad bacteria. They're good. They help you. They help you fight disease. They help train your immune system to make you stronger. And also to help digest our food for us. Yum.
We'd really love to thank the Children's University for inviting us to share some fun science videos with you, and we hope that you try some of these activities at home. If you do get a chance to try them, you're able to log these in your passports under activity and get the stamp. We look forward to seeing you on campus soon.